Hey guys, this is Stunt Rigging Toolbox Talk 4140B because I'm going to attach it to number 40 I posted yesterday. I kind of glazed over speeds and velocities and distances because, you know, everyone's eyes glaze over. Like people say when I start calculating this, they go, well, it's one of the realities of our business to know these things. So before we get some of those eager guys who will peruse this and they go, oh, you fucked up, it's this, it's that. I kind of glazed over it in generalized numbers. You can find the formulas anywhere online. And actually, on reconsideration, if you spent the time to fucking say I'm wrong, that means you've had to go online and get the formulas and calculate shit. So one way or the other, whether it's from the negative direction or the positive, you're learning something. So I really don't give a fuck. You know, it's just in our business, everybody tries to stab everybody as much as they can. Oh, that's not how I would have done it. Well, if you don't know in the fucking first place, shut the fuck up. So rather than, because I watched it again last night while I posted it, and I thought I'd be very specific, very clear, so that people can get it. You increase your speed as you progress. It takes 12 seconds to get to free fall, okay? Terminal velocity. Okay, period. And it's exponential. As you go each little bit, it gets faster. Okay, so on a stage, I was saying, you know, a 10 or 12 meter stage. Okay, and I was saying it's about a second. Well, actually, when you calculate it, it's 1.5 seconds. Because 1 second from the start of zero to gain speed, so you jump off the perms. That first second, you only go 4.9 meters, okay? And in that first second, you go 4.9 meters, and you're only going 17 kilometers an hour at the end of that 4.9, okay? The gravity constant is 9.8 meters per second. There's actually a formula. Distance equals half of gravity times the time, okay? So you can calculate, for those of you that know math or want to learn, you can algebraically transpose this, or these days with the internet, you just punch it up, they give you a fucking calculator and you punch the number in. It's that easy. Just as an example, in 1 second, you fall 4.9 meters. In 2 seconds, you fall almost 20 meters. Look at your speed. You've gone from 17 kilometers an hour in 1 second of free fall to 19. You've picked up 2 kilometers an hour. But what happens after 3 seconds? You're up to 44 meters of free fall. You've picked up 10 more km/h. So it's boom, boom, bigger steps each time, okay? So if you want to translate this to miles an hour, you multiply by 0.447, okay, on the meters per second speed. Or if you're doing meters per second, you want to know kph, you multiply by 3.6. 18 over 5, actually. So those numbers converted meters per second, okay? Because basically this tells you how many meters per second you're traveling, okay? There's formulas in there for speed, for distance, for velocity, and this is how you can arrive at it. This is just the simplest way, okay? So it takes 400 meters or 1,500 feet to get to terminal velocity. Terminal velocity is around 53 meters per second squared, okay? 12 seconds. That's about 135 miles an hour, 230. There are speed flyers who can get up to 300. They do that as a thing, you know, guys who skydive a lot that are into this, they fucking try to get as fast as they can. And you can, because of resistance, wind resistance on an object falling, which is what holds you back, you can streamline yourself down to get more speed. But let's face it, as I said yesterday, you jump out of a plane, you pancake, you're coming down, you're not trying to get as much speed as possible. That's what you're going to fall at. So given these constants, and the average height of a stage is 10 to 12 meters, generally 12 meters, you're going to be up there around 1.5, 1.6 seconds. That's if nothing slows you down, period. You jump off, you splat, it's about 1.5 seconds based on the incremental time and distances, okay? So that's just a correction. It's a simple, because I don't want anybody to think I'm speaking out of school, you can look all this shit up, okay? But rather than, because I was watching it, I'm like, oh, that's not quite accurate. It's a little confusing. But if you're interested enough to prove me wrong, or if you're interested enough to look it up, man, they've already done, you don't even have to know the formulas anymore. You can download the calculators and have them in your notebook, your iPad, your computer. And the minute you want to do this shit, you just go, oh, that's the distance. This is how long it's going to take. This is how fast it's going. Just bing, 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 literally that easy. Okay, you just got to know where to look. I download all these formulas. I've got a physics calculator, and it's all in one file. So acceleration, negative acceleration, velocity, force, trajectory for flying things to optimize how they fly and know what the path is going to be. All of this stuff plays into taking an object and flying it through space, okay? Whether it's dropping it through space, ratcheting it in a trajectory, what do you want to see? Do you want to reach this height over this distance? Well, it's going to take that much force. It's going to travel this far. And you can calculate that also. You know ahead of time whereabouts to go with your setup. That way you've got a parameter to start with. It's not just, well, let's give it a shot. Boom. Oh, well, that fucking, because we've done it. I've done it with shooting cars on huge ratchets, and we figure it's going to go X distance, and the next thing we know, it's fucking 100 meters out, and it's going through the fence at the back of the workshop and into the next industrial plaza because it landed on a one hopper, 30 yards farther, 30 meters farther than we thought it was going to be. So rather than do that on big shit, or even with people, it's nice to calculate it out. And nowadays, you don't have to know the math. You don't have to. It's got calculators online. Beep, beep, beep. And if you don't have, print them down. I keep hard copies of all this stuff. It's in books. It's in a cheat sheet. It's all available. So you can look at this. But yesterday I said it's incremental, it's exponential. As you go down farther, you increase speed more. And this kind of shows you. 1 second of free fall is 4.9 meters. 2 seconds of free fall is 19.6 meters. 3 seconds of free fall is 44.1 meters. Okay? So you're really increasing your distance, guys. Your speed is going up accordingly. So that's just a correction. In textbooks, they call it errata. E-R-R-A-T-A, not errata, like the climbing shit. But for wants and purposes here, it's a way of just making sure you get it, and nobody's going to come say, oh, you were fucked up and you did it wrong. Bullshit. Here's the formulas. Look them up. Okay, it's just an adjunct, and I didn't want to spend time yesterday doing whiteboard shit because everybody falls asleep on whiteboard shit. So, basically, it's a mirror image probably there, but you can look these formulas up. Distance equals half the speed of gravity in meters per second, and we know that formula constant is 9.8 meters per second squared. We know that gravity constant, okay? And then the time squared. So if you want to fall for 20 seconds, you square 20, the square of 20 times 0.5 of the gravity, it'll tell you how far you've fallen, okay? That'll give you your calculations. And if you need to juxtapose or use other formulas, they're available, okay? So that's simple, quick. I'm trying to keep it short, but this is the kind of stuff that you need to know prior to doing something, or if you're setting it up and thinking about it, you do it, you set your parameters first, so know what you're looking at in terms of how you're setting this up. Know what you're looking for. If somebody says, oh, I want them to have 2 seconds of airtime, you got to have at least 20 meters, okay? At least. And that doesn't include slowdown time, okay? If they say, I want them to go X speed, then you know how long it's going to take in free fall. And this is all here is free fall. There are other formulas for acceleration along linear axis. There's negative acceleration, which helps you determine your falling acceleration rate, because you can take this and then go to acceleration and see how fast you're accelerating over time. Okay, these are all important items to know. But the reality is, for everybody, your average stage is 10 to 12 meters. You're going to be in the air for 1.5 seconds, okay? And that's if there's no braking and you hit the floor. So in that 1.5 seconds, you have to know you're falling and slowdown time. In 1 second, you're 4.9. You can do the math here, 1.5 seconds, and work it out, okay? It'll tell you your distances. It'll tell you what you need for decel, etc. So a gold tail, you're going to need 3 meters of decel, and you want a second of free fall. So pretty much a 12 meter span, you're going to get you know, out of that 3 meters, you're going to get only a certain amount of free fall here, kids. Okay? So just so you'll know that. All right? Because a meter, 1.5 seconds is 10 to 12 meters. So if you pull time off of that, you're back down to this. So you're only going to get so much free fall. And you can see what that ratio is going to be. Okay? So just simple. It's a correction on yesterday. It's an explanation further. Formulas are all in books online. You can find it on your phone, all that shit. Okay? So for all you people, this is the way you calculate shit. Just as an addendum to yesterday. So that I don't get, you know, obscene messages and people trying to go, nee. It's like, fuck off. Figure it out. And here's the formulas. Okay? Just simple shit. All right? Thank you very much.